All right, this is the Math 0405 Math Foundations final exam review. And let's get started with questions 1 through 5. It says to solve. So on number 1, we have 7y plus 3 equals 38. And we want to use the property that if I want to get the y by itself, I need to first start by doing something that will remove this positive 3 from both sides. So I'm going to subtract 3 on both sides because subtracting is the opposite of addition. And when I do that, I see that I have a positive 3 and a negative 3, which add up to 0. We say it cancels out, but we know that it means that it adds to 0, which leaves me with 7y equals, and 38 minus 3 is 35. Now we need to do the opposite of multiplication, which is division. So in order to undo this 7 times y, I need to divide both sides by 7. And when I divide both sides by 7, what happens? Well, 7 divided by 7 is equal to 1. So again, we can say that this, cancels out, but it really divides to equal 1. And we are left with just a y. 35 divided by 7 is, in fact, 5. So our final answer here would be y equals 5. Okay, we can do the same things on questions 2 through 5 in order to get our variable by itself. So on number 2, I see that I have some like terms on the left side of my equal sign, and I need to combine those. So if I have 4 x's and I'm taking away 11 x's, then I should have a negative 7x remaining. So 4 minus 11 is equal to negative 7. You just combine the coefficients or the numbers in front of the variables, and your x stays as is. On the other side, negative 14 minus 14 would be negative 28. Now, again, we have this negative 7 times x, and I want to undo that, so I'm going to divide both sides by negative 7. And by doing that, I will now get a positive 1x and a positive 4 on this side. And you can always check your work by taking these numbers and plugging them back into the equation to make sure that it does give you a true statement. Okay, on number 3, we have a set of parentheses on the right-hand side, and we need to remove them by using the distributive property. Now, your order of operations tell you that you need to start with parentheses, which means you want to add inside the parentheses. Unfortunately, the two things that are in the parentheses are not like terms. X and 2 are not like terms, so I can't combine them. So I have to move to the next step, which is multiplying. So we will rewrite the left side, 12 plus 5x. And on the right-hand side, when we distribute, we get 6x plus 12. Okay, and now you have an option, a choice to make, which is which side do I want my variables to be moved to and which side do I want my constants to be moved to. I will move my variables to the right-hand side, and I'm going to subtract 5x on both sides in order to do that. Now, why did I decide to move my variables to the right-hand side? Well, I did that because I know that when I take 6x and I subtract 5x, I have 1x remaining, and it keeps it positive. I like to have positive variables, so I move it to the side where my variable will be positive. So the next step is to move the 12 over to get that x completely by itself. So I will do the opposite of addition, which is subtraction. Subtract 12 on both sides. And I find that over here, 12 minus 12 is 0. So my final answer on this is x equals 0. Okay, next we have some more distributive property, but this time it's a little bit tricky if you see this 4 minus 2 in front of the parentheses. Some may think that you should subtract that before you multiply, but again, remember your order of operations tell you that you need to multiply before you add and subtract. So I would use my distributive property first. That 4 needs to come down as it is, and I'm going to distribute a negative 2 to everything in the parentheses. This gives me negative 2x, positive 4 here, and then on the other side, when I distribute, I get 5x plus 15. Okay, now I can combine on my left-hand side here. I see that I have a 4. Oops, let me do that a little bit. 4 and a positive 4, which are like terms. So I'm going to go ahead and combine those, and we get 8 minus 2x equals 5x plus 15. And now I have the option to move my variables either to the left or to the right again. And again, I will choose to add my 2x to the other side. That way I can keep my variables positive. So I have 8 equals 7x plus 15. And I will subtract my 15 over to the left-hand side. And this gives me negative 7 equals 7x. Now I've run out of space a little bit, so it seems my spacing should have been a little bit more, but that's fine. I will move up here and write it over here. Negative 7 equals 7x. Now I need to divide both sides by 7, which gives me negative 1 equals x. And if you want, you can write it as x equals negative 1. Okay. Number 5, we have a proportion here. And when we have a proportion like this, the easiest way to work this is to cross multiply. So I'm going to take my 21 here and I'm going to multiply it up here times the x. So 21 times x. And then on the other side, I'm going to take my 14 and multiply it up by the 9. So I have 14 multiplied by 9. And of course, I still have my equal sign in the middle. So 21x equals, let's see, what is 14 times 9? Grab my calculator really quick. And I get 126. Divide both sides by 21. And x equals 6. There we go. All right, on example 6 here, it says to graph. So we have an equation, 2x minus y equals 4. And you have several options for graphing this. I imagine the plan is to use point plotting or x and y intercepts, although you can use the slope and y-intercept if you did cover that in your class. So if I want to use, let's say, x and y intercepts, then what I would do is I would find my x-intercept first by letting my y equal 0. Now you can also do this by setting up a table of points and plugging in some values. And the other option is to solve this for y and then pick some x values to make your table of points. In fact, I might go that route instead. Let me go that route. We'll go point plotting. So let's solve 2x minus y equals 4, and we'll solve for y. So I'm going to add my y over here because I think this is the easiest path. So I have 4 plus y, and then I'm going to subtract 4 to the other side. So I have y equals 2x minus 4. Now, at this point, we can make a table of points. I'm going to set up an XY chart here. And I'm going to choose some values of x to plug in here. And I think the easiest ones might be 0, 1, and 2. Or you can do -1, 0, and 1. How about -1, 0, and 1? I have grossly underestimated how much space I will need for this problem. So perhaps I will adjust. I'll have to adjust this before I hand this out in class. Okay, so if I plug in a -1 here, I get 2, yeah, gosh darn, I do not have enough space. 2 times -1 minus 4, which is -6. Actually, that doesn't even fit on my graph. Okay, so 2 times 0 minus 4 would be -4. And then 2 times 1 minus 4 would be -2. So actually 0, 1, and 2 probably would have been better choices. Here, let's go ahead and just do 2. So 2 times 2 minus 4 would have been 0. Okay, there we go. Let's just erase this one right there. There we go. So we have these ordered pairs that we're going to plug or put on our graph. So I've got 0, -4, which is my y-intercept right here on the y-axis. And then 1, -2, so I go over to where 1 is and down to -2 and put a point there. And then I have a point at 2, 0, which happens to be my x-intercept. So if you chose the route of finding x and y-intercepts, then you would have gotten these two values here. So let me go ahead and connect this. Try to make that as straight as possible. It's a little bit of a struggle, but I got that. Now, had you used slope and y-intercept, you would have gotten the same thing as well. You would have found that looking at this equation here, your y-intercept is the point 0, -4, which is right here. And then your slope is 2, which is 2 over 1. So I would rise 2 and then run 1 and put another point. Rise 2, run 1, put another point. And you can get points that way as well. So lots of options. Sorry about all the work being super cramped over here. I don't love this. So I may go ahead and just, rewrite this a little bit. So, okay. What did we get for 0? We got -4, and then 1 gave me -2, and 2 gave me 0. Okay. So the work, like I said, you can just plug in your x values this way. Now, that's not the only way. You could have just plugged in some numbers as is, the way the equation already was given to you. Pick some x's, pick some y's, whatever you like. To me, I think this seems like the most easy way to plug some values in and find points. Okay, let's look at number 7. Find the perimeter of a rectangle with a length of x minus 4 and a width of x. So I'm going to write a rectangle here, and it says that the length L is x minus 4 and the width is x. So we know that the perimeter of a rectangle means you have 2 lengths plus 2 w's, 2 lengths plus 2 widths. And we will go ahead and substitute in for L x minus 4. And then for my W, I will substitute in x. Okay, so that's what we have over here. So when I distribute, I get 2x minus 8 plus 2x. And when I combine my like terms, I get 4x minus 8. That would be the perimeter. 4x minus 8. There we go. Okay. A gallon of paint covers 300 square feet. How many gallons of paint will be needed to cover the side of a building that measures 120 feet by 80 feet? So let me go ahead and draw the side of this building here. And it says that it's 120 feet by 80 feet. And it says 1 gallon covers 300 square feet. So we need to find the area that needs to be covered with paint. So the area of a rectangle is length times width. Okay. And in this case, I mean, just 1 can be 1, whatever. Let's make this the width and make this the length. Sure, why not? So 120 feet times 80 feet. Let's see, 120 times 80 is 9,600. So my area that needs to be covered is 9,600 square feet, right? Now, in order to cover that, we need to figure out how many gallons of paint is going to be needed. Now, I know 1 gallon can do 300 square feet, so we should set up a proportion, right? So if 1 gallon does 300 square feet, then how many gallons will do 9,600 square feet? Okay, well, we can cross multiply and figure this out. So if I multiply up here, I'm going to get 9,600 equals 300x, and we won't cross multiply the units. divide by 300, and what do we get? We get 32. So x equals 32. So that means we would need 32 gallons of paint. So let me write that here. 32 gallons. Okay. Good. All right. Next. Question number 9. The standard dose of medicine for a cat is 2 grams for every 15 pounds of body weight. What is the standard dose for a cat that weighs 20 pounds? Write your answer as a mixed number. Okay, so a dose of medicine for a cat is 2 grams for every 15 pounds. So 2 grams for 15 pounds. Okay. What is the standard dose for a cat that weighs 20 pounds? So we want to know how many grams, right? Okay, well, this seems like another proportion type of problem. So 2 grams for 15 pounds equals how many grams for 20 pounds? Okay, so again, we will cross multiply and we get 40 equals 15x. Divide both sides by 15 and x equals, now 40 divided by 15, I'm going to put that first as an improper fraction and then that's reduced, and then I will go ahead and convert that to a mixed number. So if I can divide both the top and the bottom here by 5, that's going to give me 8 over 3, right? 40 divided by 5 is 8, 15 divided by 5 is 3. Now as a mixed number, I would say 8 divided by 3. 3 goes into 8 2 times. 2 times 3 is 6. And then we have a remainder of 2. So 2 and 2/3 would be our mixed number. And we are looking for grams. 2 and 2/3 grams. Okay. Find the length of the missing side of the right triangle. Write your answer as a whole number or square root. Okay, so no decimal approximations here. So we need the Pythagorean theorem. A squared plus b squared equals c squared. And the only thing that's important on a right triangle in terms of labeling is that c, the hypotenuse, has to be the side that's straight across from that 90-degree angle. So it's almost like an arrow kind of pointing you this way. This has to be c, but these other two sides can be, you know, a or b, it doesn't matter. So I mean, I can make this a and this one b down here, and it's really fine either way. So if I plug in x squared plus 13 squared equals 15 squared, then I get x squared plus, now 13 squared is 169, and then 15 squared is 225. So if I subtract 169 over, then I have x squared equals 225 minus 169, which is 56. And 56 is not a perfect square. So what we do is we take the square root of both sides, because that square root and the square will cancel each other out. They undo each other, just like addition and subtraction and multiplication and division. So square root and square will undo each other, which will leave you with just an x. And we're only concerned about the positive square root here because this is the length of the side of a triangle. It can't be a negative value. Although there are 2 answers here for x, we are only going to be working with the positive one. So the missing side is going to be square root of 56 inches because that's the units on our triangle. Actually, we should probably put it as x because they did label it as x. So let me write that. X equals the square root of 56 inches. There we go. Okay, number 11. 95% of 400 is what number? So there's 2 ways you can set this up. You can either set this up using a proportion, or you can set it up as just an equation. Personally, I like to set up the equation. Some students feel differently and would prefer to do the proportion. So either way, I'll show you both. When it says 95% of 400. The word of here means to multiply. And for 95%, we would need to rewrite that as a decimal. So 95% means per 100. So if I take 95 and divide by 100, I would get 0.95. The shortcut is to move the decimal 2 places to the left. And we get 0.95. And then of, we said, means multiply 400. And then is means equals. And then pick a letter to represent your number. How about x? What number? So you just have to take 0.95, multiply it by 400, and you get 380. So that number would be 380. So what number? The number is 380. Okay, the other option is you can set this up as a proportion, and you say, okay, 95% is 95 over 100 equals x over 400. So the of part goes in the denominator, and then you put your other number, right, the is part on the top. So when you cross multiply here, it takes, I think, more steps to do it this way, but you can cross multiply 400 times 95 and you get 38,000 equals 100x, and then divide by 100. And so then x equals 380 that way as well. So either one is good. This is either, solving by translating or doing a proportion. We have to translate to do the proportion also. So it's your choice, whichever way you like. So on number 12, 15% of what number is 90? So if I translate this, 0.15 of what number, so x is equals 90. Well, then I would just divide both sides by 0.15. And x equals, oops, let me type that in quickly, 600. All right. So 600 would be the number. All right, so question number 13 says, before taking a typing course, Jana could type 36 words per minute. By the end of the course, she was able to type 97 words per minute. Find the percent of increase, round to the nearest tenth of a percent. Okay, so first we need to find what is the amount of the increase. So the amount of increase is the difference between the new amount and the original amount. So 97 minus 36 would give me 61. So that's the amount of my increase. Now, if I want to know what is the percent of increase, so there's a couple ways you can do this, but we could set it up as a proportion and find it that way. So if we take P over 100% of, and then the increase amount would go on the top, the amount of the increase, and then over the original amount on the bottom. And then you can calculate the percent increase from here. So if you cross multiply, you get 36P equals 6,100. And then when I divide by 36 on both sides, then I get P equals, let me see here. So I need to just find my calculator really quick. And let's see here. 6,100 divided by 36 is equal to 169.4444 forever, right? And so if we're rounding to the nearest tenth of a percent, that would be 4, right? So if another 4 came after, that tells me to keep that 4 the same. Now, this is the number that's over 100. So this is my percent, 169.4%. That's what we're looking for. That's the percent increase. After 8 months, Jo Ellen has lost 75 pounds. This is a 30% decrease in her starting weight. Find her starting weight. Okay, so we need to find the, well, let's see, the amount of the decrease is something that we don't know, right? Or actually, no, we do know the amount of decrease. It says she lost 75 pounds. So that is the amount of the decrease, right? And it says this is a 30% decrease in her starting weight. So we need to know the original weight. So if I set up my 30%, 30 over 100, and the amount of decrease here is 75, and I want to know what is the starting amount. So the original amount needs to be that bottom number there. Okay, so if I cross multiply here, I get 30x equals 7,500, and then divide both sides by 30. So x equals, let's see, 7,500 divided by 30 is 250. So her starting weight was 250 pounds. All right, next. For 15 through 17, translate each sentence into an equation, then solve the equation. 15 subtracted from a number is negative 23. Okay, so let's pick x to be our number, and I'll just say x equals number. So 15 subtracted from a number. So a number, that's going to be my my x here. And then remember that is equal, or is your equals word, right? So is, that means equals. So let me put my equals there. And then when it says subtracted from, that means you have to start with the x to subtract from it, right? So x minus 15, I'm going to actually, hold on, let me rewrite this up here. X minus 15 is negative 23. And let me erase those things there. Okay. So, oh my goodness, I'm sorry. Negative 23. There it is. Okay. So a number is my x, is my equals word. And now this is the translation. So this is part of your solution. I'm going to go ahead and box that because I needed to translate first. And now I need to solve it. So in order to solve x minus 15 equals negative 23, I would add the 15 to both sides. So x equals, what is that, negative 8? Yep, negative 8. Okay. Number 16 says twice the difference of a number and 7 is equal to negative 8. Okay, so my equals words is equal to, okay, and then my number here, which is a number, that's that part. Okay, so let's see what else I have. Twice the difference. So when you see twice the difference or twice the sum or twice the product, that means you're going to put 2 and then some parentheses. So twice the difference of, and difference means subtraction, right? And you just write them in the order that you read them. So a number would be x and 7. So x minus 7. And then it says is equal to negative 8. So this would be my translation here. Go ahead and box that. And then over here, we'll solve it. So we'll distribute and get 2x minus 14 equals negative 8. And then I'll add the 14 to the other side, which gives me 2x equals 6. I ran out of space here. So 2x equals 6 divided by 2 would give me 3. So the number is 3. Okay, number 17. Why does that say the 5 times? That should probably just say 5 times the number subtracted from, yeah. Let's get rid of this word. I'll change that. So it should just say 5. 5 times a number subtracted from 3 times the same number is 4. Find the number. Okay. 5 times, okay, so again, x is going to be my number. So 5 times a number subtracted from, oh, that means that's going to come second. Subtracted from 3 times the same number, so 3x is 4. Okay, now I need to rearrange this because 3x is going to have to come first. So we want 3x minus 5x is 4. Okay, so that would be my translation. And now we need to solve. Well, 3x minus 5x, well, that's like terms. So when I subtract, I should have negative 2x equals 4. Divide by negative 2. So x equals negative 2. That would be my solution. I'm going to write that over here. It just fits a little better there. Okay. Number 18, evaluate 5x squared minus x plus 1 for x equals negative 2. This means we're just going to replace, everywhere I see an x, I'm going to replace it with a negative 2, like this. Put my square there, and then minus negative 2 plus 1. Okay, so I've just replaced all those x's with negative 2. And now we have to use our order of operations. So order of operations tells me that I need to do exponents first. Well, parentheses first and then exponents. So in this problem, exponents would be our first thing. So negative 2 times negative 2 would be positive 4. Okay. Now after exponents, then we do multiply and divide, right? From left to right. So I see that I have 5 times 4, which is 20. And then I have minus negative 2, which I'm going to write as plus 2, plus 1. And then we need to add from left to right, but we can add. So 20 plus 2 is 22, plus 1 is 23. So we evaluated and we got 23. Okay. So next thing we have on our list here, evaluate over here. Now we have multiple variables, x, y's, and z's. So we just want to make sure that we put them in the appropriate location. So for example, here, let me, I'm going to underline this here like that. Over here, I'll underline the x here with orange, and then I'll do the y in green, and then I'll do the z in blue. So that way we have some color coding here. So now on my numerator, I have 2 times my x, which is 3. And then we have minus the y, which is negative 1. And then all over 3 times my z, which is negative 4. Okay. So I replaced my variables appropriately. And now we just simplify. So we have grouping symbols, which is grouping the top stuff together and the bottom stuff together. So on the top, when we simplify, we get 2 times 3 is 6, and then minus negative 1 is a plus 1. And then on the bottom, 3 times negative 4 is negative 12. So 6 plus 1 is 7 over negative 12, which would be my final answer. You can leave it with the negative on the bottom, or you can move the negative. So you can either put it as negative 7 over 12, or you can leave it as 7 over negative 12, or you can put the negative in the front and write it this way. All of those are equivalent statements. So any way you want to write it, just pick one spot for the negative. You'll notice that in all of them, the negative's only in one location. It's not in more than one location. Okay, for problems 20 to 23, perform the indicated operations. Okay, well, I have a plus sign in between here, my polynomials, and that means I have nothing that I need to distribute. I first look inside my parentheses to see if I can combine anything, and I notice that I have all unlike terms. I have x squared, and then a negative 7x, and a negative 2, which none of those are like terms. And then I have 3x squared and a minus 7x and a plus 5, and none of those are like terms. So I then look to see if I can distribute, and I have nothing to distribute. So I can really just write this without parentheses, like this. And I have plus 3x squared minus 7x and then plus 5. So at this point, we are just looking to see if we have any like terms. So I notice that I have an x squared and a positive 3x squared. And then I see a negative 7x and another negative 7x. And then a negative 2 and a positive 5. So These are all of my like terms highlighted in their respective colors. So for my x squareds, you'll notice that this has a coefficient that is not explicitly written, but we can put a 1 in front of that if we like. So I have 1x squared plus 3 more x squareds. So altogether, I have 4x squareds. Okay? Then I have a negative 7x and another negative 7x. So altogether, I have negative 14 x's. And then last, we have negative 2 and positive 5, which adds up to positive 3. So 4x squared minus 14x plus 3 would be my final answer. And those are all not like terms, so I can't combine any more than that. Now in 21, again, looking in your parentheses, you'll note that there is nothing that you can combine. And this first set of parentheses has nothing to distribute, so I'm just going to write it down. But on this other one, since we're subtracting, we have to distribute that minus sign to everything inside the parentheses. So when we do that, what that does is it changes all my signs to the opposite, because remember we read that as opposite of. So the opposite of x squared would be negative x squared. And then the opposite of negative x would be positive x. And the opposite of negative 4 would be positive 4. Well, now we can go through and identify our like terms again. So I see that I have 2x squared and a negative x squared. Those are like terms. And then I have a positive 2x and a positive x. Those are like terms. And then I have a positive 1 and a positive 4. Those are like terms. So 2x squared minus 1x squared would be 1x squared, or just x squared. 2x plus another x would be plus 3x. So again, you can stick the 1 there if you want. And then 1 plus 4 would be positive 5. So x squared plus 3x plus 5. Okay. Number 22, similar in that we need to distribute our negative sign. So I'm going to go ahead and write down 8x squared minus 4x plus 1. I'm going to distribute that to get negative 10x squared and negative 4. And again, I will go on a hunt for some like terms. I see I have 8x squared. Oops. Let me try that one more time. 8x squared and negative 10x squared. And then I have a negative 4x, and that's it. And then I have a positive 1 and a negative 4. So when we go to combine, I have 8x squareds, and I'm taking away 10x squareds, which leaves me with a negative 2x squared. I just have that minus 4x there, so we'll write that down since there's nothing to combine it with. And then a positive 1 and a negative 4 would be negative 3. Okay, so negative 2x squared minus 4x minus 3 would be my final answer here. And you should write these in descending order. And that means put your biggest exponent first, all the way down to your constant. That's how you want to arrange these. Okay, on number 23, we are multiplying, and you have a choice for multiplication. You can either FOIL, well, there's several options that I showed my students, and that is you can FOIL it, you can use the boxes, or you can use like a vertical setup if you like, or you can use the distributive property. So there's like 4 ways that I showed how to multiply two binomials like this. So I will see what I can demonstrate here. I think the majority of my students really liked the distributive property. And so that's kind of what we went with. We said, okay, I have this set of parentheses that I'm distributing to everything inside here. Now you can do a couple different ways, or you can say I'm distributing this whole set of parentheses to each thing in here. So like 3x times 5x minus 4y plus 7y times 5x minus 4y. So we are distributing this second set of parentheses to each thing in my first set. And then once you split it up, then you distribute individually. So 3x times 5x would be 15x squared. And then negative 12xy. Since they're different letters, you just have to write them next to each other. And then over here, you have positive 35. Now, I prefer to write my variables in alphabetical order. So just like I did over here where I put the x first and then the y second, on this one, because I have an x and a y, I will put the x first and the y second. It just helps to keep things nice and organized and kind of neat, and it makes it easier to identify like terms. And then the last one, when I multiply it, I'm going to get negative 28 y squared, because there's two y's. Y times y is y squared. And now you look for some like terms, and in the middle you'll see that you have negative 12xy and a positive 35xy. And it's more obvious that they're like terms when you have the x and the y in the same order. But if you have one that says xy and the other one that says yx, they are still like terms. They just look a little different, so it's maybe a little harder to identify. Okay, so when we write our answer, it's 15x squared plus 23xy minus 28y squared. This is just one option of the 4. So what I'll do here is I think I might open like another sheet of paper, just a piece of paper, and show the other variations of how you can solve this, because multiplying using the distributive property seemed to be the one that most everybody preferred. That's what I noticed, at least in one of my classes, but in other classes I heard different things, like some people really liked FOIL instead. So I'll go ahead and show all the different ways on how to do this. So I'm going to just pause and open up some paper. Okay, so I have this problem opened up here on the right hand side. I'm just going to write it over here on the left side. So I have 3x plus 7y times 5x minus 4y. Okay, so if you would like to use FOIL, then with FOIL you just take your first two terms here, which, hold on, I don't know what color I just chose, but it's a little bit hard to see. Let me change this to like red. Okay. All right, so you take your first two terms, 3x times 5x, which would give you 15x squared. Then you take your outside terms, which is 3x times negative 4y, and that's going to give you negative 12xy. Then you take your inside terms, 7y times 5x, which would be positive 35. And again, I'll just write this as xy. And then you take, let me change that color to something else. Your last terms, which is 7y times negative 4y, and you get negative 28y squared. So after you write this out, then you've got the same thing that we had on this other problem. It just takes away one step of having to write out the distributive property. So if you prefer to write it, you know, this way, then that's fine. You still get the same answer, plus 23xy minus 28y squared. Okay, so that's the second option. This is FOIL. Okay, so distributive property over here on the paper, or on the right-hand side of the screen there. And then on the left side, we're seeing the FOIL. And now if we want to use, so this is called FOIL method right there. Now let's say you want to use the boxes. So some people really liked the box method. And the box method involves setting up a, I'm going to make up a slightly bigger box here. Setting up a 2x2 box, so that way you can put your things like 3x and 7y here. Sorry, this is a little bit light. Let me try that again. So 3x, 7y, positive, and then up here on the top you have 5x and minus 4y. And what you do is you take where they intersect and you multiply those pieces and put it inside those boxes. So let me zoom in just a bit here. This. So 3x times 5x would give me 15x squared. And then 3x times negative 4y would be negative 12xy. And essentially what you're doing is you're taking and finding the area of each little box. And then at the end, you want to add up all of those little areas to find the total area of the box. So they call this kind of an area diagram. So 7y times 5x would be 35. Again, I'll say xy. And then 7y times negative 4y would be negative 28y squared. And at this point, you now need, this is the area of each of these little boxes. So you would then add up all of the areas, and you'll find that you have some like terms here and here. The other two are going to be different. So you have 15x squared. Combine your like terms to give you the 23xy. And then you have your minus 28y squared. So again, same answer. Obviously, you should get the same answer for all of these. That's a second or a third way to do this. Now, the last way, which was somewhat unpopular, but I'll still show it, is a vertical method. And the vertical method has you setting up your things 3x plus 7y. And then your other one, 5x minus 4y here, and then you're multiplying. So just like we multiplied before with numbers, you start here, negative 4y times 7y is negative 28y squared. And then you move over to the next one, negative 4y times 3x would be negative 12xy. And then you put in a 0 here, right? Because that's what we did when we moved to the next place value. So drop in a 0 there. Then you multiply 5x times 7y, which is 35xy. And then 5x times 3x would be 15x squared. Then you add up your columns. So negative 28y squared. Here we get 23xy. And here we get, that's positive. And then we have 15x squared. Which, again, same answer, right? Slightly different way of looking at it, so you probably haven't seen it that way before, but this is all the different ways. This of course is the distributive property over here. So take your pick. I've given you four options I mean, and you choose whichever one you like. Okay.